take the apple to reach its highest point?
I know how to find out. Physics!
Look! He's doing work!
Physics!
Look, guys, our images are virtual!
And direct.
Physics! Physics!
One of the most well-known aspects to physics are Newton's laws. This has to do with what we call force. A force is basically a push or a pull, or the most common is gravity.
This famous guy you've probably heard of, Isaac Newton, came up with a few laws that we have to follow. They're more theories, but they're pretty accurate. Newton's first law is the law of inertia. The law of inertia, which you'll hear about on your driving test, states that a stationary object remains stationary, which is basically saying if something is standing still, there is no force acting upon it. It will indeed stay still. However, if there is a force acting upon it, making the object move, it will continue in a straight line at a constant speed.
For example, if you're driving in a car,
Hi, my name's Cam.
as you're driving quite fast. You feel yourself turning a corner and the car not wanting to turn with you. The car wants to keep going straight. Or if you were driving said car at, per se, 110 kilometers per hour, not wearing a seatbelt, and you had to crash, your body would continue to fly through the air at 110 kilometers per hour. No! No!
Newton's second law is more of a mathematical equation.
Algebraic!
Mathematical!
Rhombus!
It states that force is equal to mass times acceleration.
This all depends on the object's weight, which is calculated by mass times gravity, which is always 9.8 meters per second. Weight is measured in newtons, which is the same as kilogram meters per second. We can get a fun formula out of this, which is F equals mg, or force is equal to mass times gravity. For example, that's why it's easier for someone to push something light, rather than someone trying to push something heavier.
Finally, we have Newton's third law.
Which is probably the most well-known law.
And one of the most used in physics.
Newton's third law states that
For everything.
there is an equal and opposite reaction. And so I push on Keanu.
I pushed back on Michelle.
Another example is a car driving. As the force of the wheels pushes on the road pushes back on the wheels, propelling the car forwards.
When swimming, you push the water backwards as the water pushes you forwards.
I mean, we love physics. I mean, we just wish we could take all the physics in the world and put them on a rainbow and roll around with it. I'm sorry, we get emotional when talking about physics. 'Cause you never know when you'll need to use it in real life.